All right, so when you see something like this, because I think that's just a regular x right there, right? This is a fundamental theorem of calculus that you got to know. And what this means is, since you have something equal to this is a derivative of that something. So this is the same as g prime of x. And then you take that x and you stick it in where the t is. So what that means is the derivative of g is equal to the function f. So if you look up here, it says f is the function graphed. What that means is not only is this graph f, this graph is also g prime. G prime and f are the same, so that is the graph of g prime. And it's kind of a huge deal, you know that. It's going to be on the AP test. So we come down here, and we are supposed to be finding these values of these functions. So we're going to use the other fundamental theorem of calculus to do this. So you said which letter? C? Mm-hmm. All right, so I want to find C. So what I need to do is get a starting point. So since the original problem said 0 to x of this function, if I said 0 to 0, if I made the width of my base of my rectangle 0, what would the area be? 0. So what that tells me is f of 0 is 0, which is the same as saying g prime of 0 is 0 because these are equal. Okay, so we know f of 0 is 0 because if these match up, there's no area. So that means the y value starting right here, the y value of this derivative is 0. Okay? All right, now we want to find g of 4. So what that means is I'm finding 0 to 4 of f of t dt, which means because of this thing up here, that is, I would not write this on the AP test. I would write this right here, and then I would go directly to what I'm writing right now. That means that's the same as g of 4, the integral of 0 to 4 g prime of dx. Does anybody know what the integral is of g of prime? What's the antiderivative of g prime? Anybody know? It's g. That's opposite of derivative, so it goes the other way. So that means that this thing right here, and I'm going to write it down here so I have room to write it. I'm going to write the fundamental theorem of calculus out right now. So that means this is going to be g of 4 minus g of 0. Oops. I kind of lied on this. My bad. Up here, I wrote that wrong. So look at this. Fix this if you didn't. So this means I'm doing the integral of 0 to 0 of g prime of x, which is g of 0. And that is going to equal 0 because there's no area there. So g of 0 is 0. So what I'm going to do is I'm going to find g of 4. So I know this is 0, so it really doesn't affect anything. But g of 4 means I want to get the area of this picture from 0 over here to 4. So this area right here, this is a trapezoid. So this is going to equal, by the way, this is g of 4. Let's do this. I'm looking for g of 4, and I'm going to do the area from 0 to 4 here. So this base is 3, plus this top base is 1. The height of this trapezoid is from this base to that base, which is 2, all over 2. And then I got to get the area of this little triangle right here. So this area of this triangle is going to be a negative, so it's minus 1/2. The base of this is that 1, and the height of that is 2. So what that means is I got these 2's reduced out, and I got 4 minus 1, which is 3. G of 4 minus 0 is just g of 4. So there's my value. This value right here is 3. You follow where that came from? And you said what other one? I think somebody said E, so let's do E now. So here's what the difference is. It's not a big difference, it's a little difference. Instead of 4, this is going to be 11. This is going to be 11. This is going to be 11. And this is going to be 11. Okay, so this becomes 11, and this becomes 11, and now I got to get the area from here all the way over to here. So I already did this part. This was 4. This was negative. Well, no, I'm not going to worry about the -1. I'm going to get this whole triangle right here. So this base is 3 times 2 is 6, and half of that is 3, and it's underneath, so that area is 3. I'm going to make this into a triangle right here. Get the area of this triangle, so this is 3 times 3 is 9. Half of 9 is 4.5, or 9/2 if you want to write fractions. Okay, so we got this area to here, and then I got to get this area. Well, this area is tricky. So I need the area from this quarter circle. That's a quarter stopping at 11. So I've got to get the area of this part down here. Well, back in geometry days, that means we got to get the area of this rectangle. And once we get the area of that rectangle, we subtract out the area of this quarter circle right here, and that'll be that area. So you go area minus that quarter is going to be that part. So the area of that rectangle is 2 times 3 is 6. So I got 6 minus, and I need the area of this quarter of a rectangle. Well, my radius of the rectangle is from here to here, which is 2. So the area of a whole circle would be pi times 2 squared. But it's how much of a circle? A 4. So I divide that by a 4. So these reduce out. So that's pi. So that means this is pi right there. So the area of just the red part, I'm sorry, I put the pi in the wrong spot. The area of this is pi up here. So the area down here of this is 6 minus pi. So that is 6 minus pi right there. So that is the area I need. So I'm going to add all of these up because that's what's going to be, that's what this part over here on the left is going to be. It's no longer just this part, it's all those areas total. So this part over here is 4 minus 3 plus 4.5 plus 6 minus pi. So if I add all these numbers up, let's see, that's 10. 10 minus 3 is 7, and 7 and 4.5 is 11.5 minus pi. So that would be what that problem is right there. G of 11 would be 11.5 minus pi. I think somebody else had a different one. Did somebody here say a different one? H. We're going to do H. Now, H says, what's G prime of 13? Can anybody tell me what's this a graph of again? G prime. That's G prime. So all that wants is at 13. What's the Y value right there? There's your answer. 3. Because that is the G prime graph. Anybody else in here have any questions on anything or at home? What?
The line. So, is G prime?
The graph is G prime. Now here's Y again. Here's why it's G prime again. It tells me up here that F is the graph, right? F is the graph. So that means this graph right here is F. They got Y there, but it's really F. Okay? This thing right here, the second fundamental theorem of calculus says if you get a function equal to the second fundamental theorem of calculus, it gets you out the derivative of that function. And when you plug in that x for that f of x, that gives you that G prime is the same thing as the graph of f, or f itself. G prime and f are equal, so not only is that the graph of f, this is also the graph of G prime. They're the same thing. That's what that fundamental theorem of calculus tells me right there. Okay? So that's kind of something you got to memorize, that if it's written like that, it's giving you a derivative. Does that answer that question, Olivia?
And then the point of...
Then you're talking about H down here? Okay, so when I look at H, it's saying, what's the value of G prime when x is 13? And since this is the G prime graph, that means when x is 13, G prime's the y value, just like it'd normally be the x value, but these two things are equal. So if I said what's f of 13, that's the y value right there. That's 3. Well, f of 13 is the same as G prime of 13 because of what that thing says up there. So they're both 3. It's the same value. Does that help?
4 minus 0 is just a rule. So G for 4 minus G is 0 is just a rule.
Okay, well, G is not the same as G prime, right? These say G. So these are saying what is the original compared to this derivative. This is the derivative of G function. So if you remember, that means if we do the integral of G prime, that equals G. So because an integral and a derivative cancel each other out. That's an antiderivative and a derivative. They cancel each other, just like adding and subtracting cancel. So when I do the integral of this function up here, that's giving me G. So when I do integral, that means I need the areas under the curve. Yes or no?
That makes sense.
Okay. Anybody else got something? Any other question on anything? 6, 4, 6, 5, 6, 6, 6, 7. Wait a minute, we got one on here. Can we do 15? We can. Is that 15 on 6, 4, 6, 5? Sorry, F. You mean you want to do F on number 1? Okay, we're going to do F on number 1. It says what's G prime of 15? Once again, it says just G of 15, not G prime. This is just G of 15, okay? Oh man, I erased all those. So I'm gonna go back so I have all those areas back up there if you don't mind. Come on, machine, get there. Man, change a lot. Oh, there we go. All right, so we found all these areas, but this says we're now going to go all the way to 15. We're not stopping here at 11. We're going all the way to 15. Well, this area was 6 minus pi, so this area is also 6 minus pi from the same reasoning. The area of the rectangle minus the area of that little semicircle. So those are both 6 minus pi. Okay, from the exact same steps. That's to here. Okay, and then this, here, let me think about this real quick. I'm going to get the area of that hole. I want to get the area, so, yeah, that should be exactly the same. This, again, we're doing the area of this rectangle, which is 6, minus the area of this little quarter of a circle, which is also pi. So that's 6 minus pi, this is 6 minus pi. So that whole area down there is 2 of those. And then we got this triangle over here is the last area to get to 15. So we got 3 times 3 times a half. This is also 4.5. So we are doing, for this problem right here, we are doing the integral from 0 to 15 of G prime of x dx. Okay, that's what it wants us to get. And again, that would equal G of 15 minus G of 0. Well, we already said because 0 is up there at the top, that if we went to 0 to 0, that means G of 0 is 0. So we plug 0 in for this. Okay, so this goes away because this is nothing. So in other words, G of 15 is going to equal whatever this is, which is the area from 0 all the way over to 15. So all I got to do is add up all these areas. So 4 minus 3 is 1. 4.5, and that 4.5 is 9. So 1 and that 9 is 10. 6 and 6 is 12. So 10 and 12 is 22. And then I got those 2 pi's in there. So this should be 22 minus 2 pi. Yes or no?
Is the second 3 and 3, or is it 2 and 3? Is the bottom
Say it
side-
again.
Is the bottom side a 2? It's 13 and 15.
13 to 15. Oh, you're right, I got the last area wrong. It's not 4.5, it's 2. Thank you. So that's 2 times 3 is 6, so this is actually 3. So I should have this 1.5 less than that. So 22 minus 1.5, I think it's 20.5. Yes, I did terrible math. Thank you. You saved us, Donna. So it should be this. This should be the answer for that one. Does anybody else have any you want me to do? You guys need to practice these. These kind of problems are going to be on the AP test. They always are. It'll be part of one of the, I should, definitely this stuff will be on there somewhere. Nobody's got any more questions on anything? 6.4, 6.5, 6.6, 6.7, 6.8. I've given notes all the way through 6.8. You guys at home, we're going to be turning in 6.4, 6.5 tomorrow, and we should be also ready to turn in 6.6, I think. Okay? You guys in here, are you done with 6.4 and 6.5 or not? Okay, well, you need to get those finished up. I need through 6.8 from you guys by Monday in here, okay? Because we got to get through all this stuff. Found out we're having a mock exam coming up in March. Which what that means is we're going to take an actual AP test. You're going to see what it's like. Now the only bad thing is I got to break it up over 4 days because of time, and you're going to have to do it all in one day. So you're going to get breaks between that you're not going to get on the real day. You get a little breaks, but not a whole day. So you're not going to get the total thing, but hopefully it's going to stress you out a little bit because of time. I want you to feel the stress, so you work under the stress, because that's what it's going to be on that test day. Anybody at home got any other problems you want to see? Oh, I want to shut off this video. I'm putting stuff on here that